Now we're going to talk about planes. This says a point P and vector n, the set of all points Q satisfying the equation n dot PQ equals 0. Now think about what n dot PQ equaling 0 means. That means that I'm actually dealing with orthogonal vectors. So when this equals 0, that means they're orthogonal vectors. Now it says the set of all points Q satisfying the equation n dot PQ equals 0 form a plane. The equation n dot PQ equals 0 is known as the vector equation of a plane. So we're going to talk about that first, just that idea there. So in essence, it says the set of all points Q satisfying the equation where the dot product is 0. So let's take a look at that here. So I have this 3D coordinate system set up, and what I want to do is I just want to take this plane here and I want to put it on that or in that rectangular coordinate system. Okay, so when I look at this here, in essence I have this n, which is here, and if I think of any points on a plane, now this isn't a plane initially. By definition it's a plane if it meets that condition. So let's say this was my P here. So my P is going to be here at the end of where this vector is, the initial point. And Q can be anywhere. So I'm going to put Q here for now. And I'm just going to draw this vector. Now, if that creates a right angle or orthogonal to that n there, that vector PQ, then I can say that that point's on the plane. And that's really what we're dealing with here. So all these points that meet this condition, so I could pick that one, or this one. Now again, I picked them in the right way, and I picked them in such a way that they were on the plane. So if I picked one way over here and I drew that vector, then I would say, oh, that wouldn't be a right angle. That could probably be larger than 90 degrees or something. So that point wouldn't be on the plane. So that's kind of how it works here. If I pick a point and I create the vector and that's orthogonal, then it's going to be on my plane. That's really what it's saying here. So if you think about all of those points, no matter where I put them at, that are on the plane, those are all going to be right angles. And that's all I wanted you to see here. So we can get a nice little visual of what's going on. So the weird thing about this is n is really giving us the direction of the vector. Not the vector, the plane. Which is kind of strange in a way, because in most cases when we deal with direction, whatever components we have are generally in the same direction as that object. Like with lines, right? The slope just goes up and over, that kind of thing. It seems to fit that way. But when we're talking about planes, our direction is by the orthogonal vector that we call n. And in essence, it doesn't go in the direction of the plane, in a sense. It's not like a line this way. It actually goes orthogonal to it. And that's how we create the direction of a plane. So that n is always orthogonal to the plane. So keep that in mind. And again, this form right here is the vector equation of a plane. That form. Okay, we also have a scalar equation of a plane. And this is a different form. This is what I'm more accustomed to seeing in most books, this scalar equation of a plane. So containing P naught, X naught, Y naught, Z naught, with a normal vector n equaling ABC. And the form is here, where A, X minus X naught, plus B times Y minus Y naught, plus C times Z minus Z naught equals 0. That's the one I'm more accustomed to, because if I have a vector here and a point, that vector, there's my A, there's my B, there's my C, and then X minus X naught, X minus Y minus Y naught, and Z minus Z naught. That's just what I'm used to seeing mostly and dealing with mostly. And this equation can be expressed this way here. AX plus BY plus CZ plus D equals 0. And then notice what they say about D here. D equals negative A times X naught minus B y naught minus c z naught. Now again, all they did here to get this form down here where d equals this is they actually just distributed through, and anything that wasn't just an XYZ, they called it D. They put it all together. So that's how you get from that form to that form. Not too bad. And it says this form of the equation is sometimes called the general form of the equation of a plane. So that's this one down here. This is the general equation, the general form of the equation of a plane. But mostly this is sufficient for most things we do right here. The scalar equation of a plane. So I got a problem down here now. This problem says find the general form of the equation of a plane that passes through point P and has normal vector n. Given P equals 1, 2, 3, and n is the normal vector 1, 2, 3. So again, in order to find a plane, all I need is a vector and a point. And not just any vector, that vector has to be the normal vector. Now again, if I was just given a vector, that wouldn't be enough to find a plane. Now it would be for a line, but not a plane. I need the normal vector. So that's what's more important here. So I can't just have any old vector. It has to be normal. Okay, so anyways, so now I have all the information I need for this. So here's actually the one I'm going to use here, this form here, the scalar equation of a plane. And I'm just going to plug it in. So think about it. My n is 1, 2, 3, so that's my ABC. So I'm just going to get a, which is 1, and then I have this parenthesis x minus, and my x naught is going to be 1, so minus 1, and then plus 2, and then my y minus my y naught is 2, okay, plus my c is 3, and then that's going to be z minus 3. And that equals 0. So we're done. We did it. Now, if we wanted to put this in standard form, which I will, so this here is my scalar form. If I wanted to put it in standard form, I definitely could do this pretty easily. This is just a little simple algebra here. So I distribute the 1 through here. And that would be x minus, I was going to say plus 1, minus 1, plus 2y, because now I'm going to distribute that through. So 2y minus 4, and plus 3z minus 9, and that equals 0. So now all I'm going to do is put my numbers together here. They're all on the same side, so I can just put them together. All right, so that's going to be x minus or plus 2y plus 3z. And you can see how those x naught, y naught, z naught is d now. Because that's negative 1, negative 4, that's negative 14 equals 0. So now you can clearly see why this form down here, that d is actually that negative a naught minus by naught minus cz naught. You can see that now. So it's kind of nice. But that's not our answer there. I just want to show that to you. This here would be sufficient for the answer for this one here. Don't have to multiply it through and stuff. Some of you will, and that's okay too. Either way, I'm okay with. And for this form here, I don't really see very much. I really don't. It's the other two forms that I see more frequently. So just kind of keep that in mind. And I'm not going to be big on what form you should have to begin with. Like I said, one of these two forms at the bottom are probably the most common.